like the father. So melody and rhythm are kind of the basis or the crux of musical organization. And music without rhythm, rhythm without the pitch and the tone really can't be music. So it's almost like the same side of a coin. You cannot keep them separate. They go hand in hand. And uh, rhythm is also another important component which kind of intuitively appeals to everyone, be it babies to elderly, and rhythm is in every aspect of our life, including other non-musical domain of functioning too. There is rhythmic waves in the brain. There is rhythm in the way we speak. There is rhythm in our gait, our walking. There's rhythm everywhere, including our heartbeat. So rhythm is a very phenomena as such, is a terminology used to kind of measure time. And music is something that unfolds in time, and it's a dynamic process. So music as well as rhythm is kind of considered as the fundamental principle or the organizing principle of brain function as well. Um, but there has been a lot of debate in the field of neuroscience as to what really music is playing a role in our lives. Here I mean music inclusive of rhythm. So does it really have any specific role to play, or is it just like an entertainment that's existing in our lives? And music is kind of was considered by Darwin like a precursor of human language. It was like considered as a primitive song-like communication, which predated language, but it really doesn't have any adaptive role to play. So in that sense, primitive song-like communication, or that kind of non verbal kind of signals that humans produced, was considered as something that kind of led to music, and then that kind of was became a spandrel or a support mechanism for language development. So earlier evolutionary theorists, and more so the Darwin, the father of the evolutionary theory, mentioned that music is neither an enjoyment nor the capacity of producing notes, or music is kind of the least of the behavior that has any adaptive role to play. And that continued for even until recently, saying that music perhaps is like an auditory cheesecake. It kind of tickles the adaptive function, although music per se does not have any role to play. And it seemed like a byproduct of natural selection, kind of to tickle the sensitive spots of those functions, including cognitive functions like language or other cognitive functions or motor functions that perhaps have adaptive role to play, and music really didn't have. But that's not true. I'll come to the crux of what neuroscience says today and what we understand about the role of music and rhythm has in our lives. And Darwin too, in his theories, changed his opinion. In fact, he said that our capacity for music has deep evolutionary roots, and argued that the perception, if not the enjoyment, of musical cadences and of rhythm is probably common to all animals, and no doubt depends on important aspects of their nervous system. So we kind of kept the enjoyment component separately versus how the brain perceives music and rhythm in terms of cognition. So actually, the field of music, rhythm, understanding of how we perceive music and rhythm isn't something new. Even if you take from Indian tradition point of view, music is considered to be an age-old form of pedagogy or knowledge, and not just mere art form. And music, just like mathematics or other physical exercises, were considered to be extremely important for an overall development of a human being. And if you look at music cognition per se from the West, did have its origins even 2000 BC, and it kind of was way before the establishment of the current experimental psychology as we know of. And of course, Pythagoras argued that musical intervals should be classified by their effects on the listener. So by then, they kind of saw that the temporal aspects or the psychoacoustic aspects of music and rhythm does play an impact on the listener. It does impact the emotional processing. And it should not be merely examined as mathematical ratio as in what interval does pitch 1, pitch 2, or pitch 3 have to each other. And of course, the earlier studies of experimental psychology actually dealt with acoustic auditory processing and more so with music. In fact, Gestalt psychology, one of the very powerful, foremost school of thought in psychology, try to address this relationship between the whole and how we understand the environment in terms of cognition, was attempted through relationships in music and melody. So in that sense, music and rhythm is not truly an adjunct kind of behavior, but truly it's so biologically based, it's so inherent in humans. And I'll just show an example of how even young babies, and there are a number of examples, but here I have just put out a few examples to show how rhythm, which is an inherent feature of music, plays a very, very crucial role in terms of entraining our bodily movement and also to the external auditory information that comes about. Okay, so for example, here is a 9-month-old child who kind of moves her head to the rhythm that's played. And we do know that when we talk about rhythm, there are certain beats that are a little high in terms of pitch or in terms of its acoustic property, and some are that are very soft. And here in this example, we see that the child is actually nodding her head to the upbeat, that we say the strong beat versus the weak beat. And of course, there are exceptions. A 3-year-old child there are examples where there are child prodigies of who can excel in rhythm and rhythm production as well as perception. And in cases like these, often music is considered to enhance through experience. Through training. So, of course, there are certain inherent features that we are born with, how we respond to rhythm, but there are also certain semantic or the syntax, like language, that we develop as we grow. Developmentally, that we acquire certain inherent knowledge about the structure of the music, structure of the rhythm, perhaps keeping in mind the cultural variations that come about. And there are exceptions. In certain traditions, like in the Indian traditions, rhythm can be as complex. So it's just like language with its hierarchical features, starting with simple beat, going on to be a complex one. And as I said, training plays an important role. And here is an example where an expert musician, we all know Zakir Hussain ji, who is one of the leading exponent of tabla, the tabla maestro, who plays complex rhythm presentations, like 9-beat rhythm cycle, where he brings it within a 7-beat pattern and things like that. So I'll just play this as an example. Perhaps for novice, those who have not been trained in music, getting the upbeat and the low beat, as I showed in the previous examples, would be difficult in an example, in a sample like this. Nevertheless, the point that I'm trying to make through these videos is that, one, music of course, manifests across time. It's a dynamic process. The urge to move to music and rhythm is universal among humans. It could vary, of course, in its complexity based on learning, the cultural variation, and just like language, acquiring complexities through formal training. And when we are talking about effect of music, how we get carried away by music, often it is through the movement or what we call as entrainment to the rhythm as well. And usually the temporal qualities of the music, for example, its pulse, the beat, the rhythm, plays an extremely important role when we express our liking and our perhaps external behavior of appreciating music. So before I dwell further, I thought I'll take you through some of the technical terms which we should know when we are talking about music and rhythm, and then move on to its relationship with the human brain. There are certain terms that are often interchangeably used. We use the term beat. Oh, the beat of that music is really good. But beat is actually the basic unit of time. It's like the pulse which keeps repeating. For example, here it's just a metronome which keeps going on. This is kind of beat. And often tactus, the next term that I would like to introduce to you, is interchangeably used, often synonymously used with beat. When we talk about rhythm, there is serial pattern of variable note or duration in melody, characterized by repeating sequence of stressed and unstressed, what I earlier mentioned as the strong or the weak beat. For example, if it's the same example of this metronome sound, imagine I make tuck, 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 tuck. There's an upbeat and a low beat. So here I'm adding another feature to this beat. And tempo, of course, which is a common term that we all use, talks about the pace of the music or how often this beat comes in a given point in time. So tempo is also strongly associated with beat period. That is, if this is a 60 beat metronome sound, you could have something that comes at 40 beat, 30 beat, which means you or increase it to 70, 80, 100, so on and so forth. So you have more such events coming in a given point in time. Then comes meter. Meter is in a hierarchical way, an additional component to this rhythm perception. Meter organizes into perceived series of beats into regular repeated patterns of stressed and unstressed beat. For example, if I keep the same example of this metronome sound, imagine I say 1, 2, 1, 2, or 1, 2, 3, 1, 2, 3. So I'm bringing in a repeated pattern of the same beats into its cyclical manner. So meter is like timing framework given under which a pattern of rhythmic duration is understood. Now, if you look at this slide on the right hand side, it's the hierarchical organization of the Western notation system of a whole note which has 4 beats. Then you have the half note which is 2 beat, the whole note divided into 2. Then you have quarter note, 8th note, 16th note, and so on and so forth. And even in the Western notation system, you have any musical script or the piece written with 3/4, 6/8, or 2/4, basically indicating which note are you talking about and how many of those notes in a given bar. So these are just like language. I'm just trying to make this point clear to all of you that it has hierarchical features. They're all placed from base, a simple feature to a more complex feature. Now, coming to musical beat perception, there are few key aspects of human beat perception. One is that it is predictive. That means perceiving a periodic pulse by moving rhythmically in synchrony with the pulse. We all do that. We predict. We have the ability to predict when the next beat is going to come. And this predictive component has an evolutionary basis to it. And listeners often express their perception of pulse by moving rhythmically in synchrony with the pulse. So whether they may get the meter or the higher complex aspect of the tempo, but nevertheless, individuals universally are able to get this pulse and be able to anticipate the next beat that is often going to come. In fact, this prediction of auditory beats has broader impact on cognitive consequences, including it facilitates motor planning, motor timing. It also is known to facilitate learning and recall of strongly beat inducing rhythmic patterns, or that would be an inherent component of various language aspects as well. The next important thing is that musical beat perception, it can be flexible across a wide range of tempi, often beat in a range of about 250 millisecond to 2 seconds. Individuals are able to appreciate and perceive that, but intervals between 400 to 1200 millisecond give the strong sense of beat. The the next important aspect of musical beat perception is that it is constructive. It involves more than just passive entrainment of responses to sound. We also are able to, kind of, uh, how do I put it? Like, for example, you're able to synchronize with rhythmic sequences and also be able to voluntarily shift these phases as and when your internal beat can vary. Let me give an example to explain this further. Is that if I give you a song like Happy Birthday to You, and often we'll have ability to say Happy Birthday to You, you could have this beat that goes on 1 2 3 and 1 2 3 and goes on. There are some people who may want to give two beats for this particular song. So Happy Birthday to You, so two beat coming in within a sequence. So you have the flexibility as well as ability to construct and not just passively entrain to this neural response to sound. Often we may have syncopation. That means although a song is going on, internally you may vary the entrainment and give an offbeat, the beat that goes on. So if you want to say 1 2 1 2, you may actually tap on 2 rather than 1, which is actually the upbeat and not the weak beat. Basically trying to highlight the point that there is a lot of variation, lot of components that we are talking about when we discuss about beat perception or rhythm perception. The other important point is that musical beat perception can be hierarchical. That is, it can be arranged in patterns that can create higher level of periodicities. So, for example, you might, same example, if we take Happy Birthday to You, you might say Happy Birthday to You, and then go on with beat 1 2 1 2, or increase the beat as I mentioned just a while ago. The other aspect is you may give the metrical component to it. So you can actually place these features of rhythm in its multiple hierarchies. Just like in Indian classical system, you might actually make it into higher periodicities of 16 beat, 7 beat, or within 16 beat, you might actually divide it in its beats further and make it, like 48, 36, and so on and so forth. So another important aspect of human brain and rhythm perception is that there is modality bias. That's evolutionarily, perhaps there is a role to play. But when an information is given auditorily, there is a higher chance of entrainment rather than giving it in a visual form. There is, of course, studies being done even on primates to see if there is a difference between humans and primates when it comes to this modality bias. But often, if you give an auditory cue which is rhythmic in nature, there are high chances of individuals and training to it compared to giving the same information visually. Imagine visual light coming, of course, rhythmically, but when the same information is given auditorily, many of these hierarchical features can be perceived far easily than in visual modality. So there is an inherent modality bias when it comes to rhythm perception. The next important point is that rhythm perception engages the motor system. So, pure perception of beat in absence of any overt movement is known to engage the motor areas of the brain. This perhaps is so very crucial in helping or in thinking of how music has perhaps played a role, an adaptive role evolutionarily, and also how in the current field of neuroscience, music is actually being be able to translate to a clinical setting or in terms of neurorehabilitation. I'll come to that in a while later. So what it actually does is when this perception of rhythm is occurring, there is also an engagement of the premotor area, the basal ganglia, especially the putamen, and supplementary motor area, which are all the crucial brain areas involved in motor perception. Now, this is an example, figures that I have put forth to kind of highlight this point a bit further. Now, there is coupling of certain brain areas through neuroimaging studies, that is fMRI studies, Jessica Gran, Anirudh Patel, and there are Hengden Hoing. There are people who are working extensively in understanding this, how human brain perceives rhythm or even features of rhythm, as I mentioned earlier on, beat, meter, and other complex hierarchical feature of rhythm perception. This particular image that's on your left-hand side actually shows neuroimaging data of how beat perception has actually activated, obviously, the auditory perception area, but as well as the supplementary motor area and the putamen, which plays a very important role in non-musical domain of motor functioning and motor coordination. Now, coming to the images that are placed on the right-hand side, what I would like to highlight is that there are two main streams. One is the dorsal stream and the ventral stream in the human brain. It's true of visual system, it's true of auditory system. Now, it is known that the entrainment to beat or entrainment to rhythm actually also activates the dorsal system of the motor pathway. And this also includes the parietal area, that is the region where you could, you're seeing here, angular gyrus region here. And that's actually a crucial area even in language processing. So there are theories that are now put forth to understand how music or rhythm perception actually can have a transfer effect on other cognitive functions such as even language function, and can actually have impact on the motor system or the motor pathways. So crucial areas that are involved is in this dorsal and the ventral stream. Just to explain to those who perhaps are not from the neuroscience background, the dorsal system is also known as the where pathway and the what pathway, and the ventral system is known as the where pathway. That means, where is this sound coming from and what is this sound? Or in terms of rhythm perception, the beat as well as how this acoustic features are all coming through. And integration of both this information includes certain crucial areas of the brain that is implicated in language processing as well as in motor functioning. Motor functioning as in fine motor functioning, gross motor functioning such as walking, hand motor control, and upper limb, lower limb control, so on and so forth. So this is another figure that I have put forth to highlight the key point that in the field of neuroscience and to answer the challenges that were put forth from several scientists saying that music really does not play an adaptive role to play. Today, in the field of neuromusicology or music cognition, music psychology, what we know is that music engages almost all areas of the brain. And if you're talking about rhythm as an integral part of music itself, then it does engage the the brain area that is crucial in the prefrontal functions, what we say as attention modulation, because rhythm actually activates this attention allocation, has the ability to kind of modulate because of this inherent need to anticipate the beat that is coming up in dynamic time point. So to explain this a little further, if I'm giving you a certain beat like 1 2 1 2, you after a few seconds you would know exactly 1 is going to come and 2 is going to come. There may be minor variation if I ask you to tap, but more or less uh, all neurologically intact individuals should be able to tap on beat and have this expectation of when the next beat is going to come. And this is also a crucial component which actually activates the attention system. So you have the rhythm perception, which kind of modulates and facilitates higher cognitive functions such as attention, allocation of attention, coordination of motor functions, and entrainment of this motor pathway, as well as include in this processing the language areas. Now, why all these are important, I'll come a little later in my slides when I talk about the clinical implication. So, what do we know as of now in the field of neuroscience of music is that music and rhythm engages the basic auditory pathway, which is quite obvious. We all know that it would engage these primary auditory area and the whole auditory pathway, the neural pathway. But importantly, it also engages the syntax network, as I said, perceiving higher order of these features. In terms of music, the features are a bit different in terms of pitch, tone, interval, harmony, chord, and so on and so forth. What we are focusing in today's talk is actually to understand features of rhythm, beat, tempo, meter, and so on and so forth. The other pathway that music and rhythm engages, as I mentioned, is the attention and working memory network, focusing and keeping track of music that unfolds in time, and motor network. So one is to entrain to the rhythm, the external cueing. There is actually two pathways in the human brain where there is an inherent, rhythmic pathway that is there, and an external rhythmic pathway. And these two get coupled in terms of when we are talking about rhythmic entrainment. And the other important aspect of music, of course, as we know, is the reward and emotion network. Music per se, the sound, the harmony, the chord, is a lot more studied in terms of its association with music. But what we also know is that variation in tempo, the tempi, the speed, or the density of the beats coming in duration of time can also play a very important role in emotion, expression of emotion, and perception of emotion. So, all neurologically intact individuals appear to be born musical, have rhythm sense. Just like specific learning disability, what we know is that about 4% or little around that people do have amusia or arrhythmia. That means in a distinct lack of ability to perceive music or rhythm perception. The other is acquired conditions, when there is an injury to the brain, to the crucial areas of the brain where rhythm or music perception may get affected, and even there selectively affected, just like how somebody, if they have deficits in language, can have selective impairment of language processing. Same thing could happen with music and rhythm. And prior to 1 year of age, pre-linguistic infants are known to display remarkable musical abilities. I did show a video, and I'm sure on the social media and YouTube there are several more such examples where young babies and do respond to music and rhythmic abilities. I'm not talking about just the prodigies, but there are just handful of them, and the whole lot of theory to understand such population is quite different. What I'm talking about is the normal distribution of music and rhythm perception. And individuals do show, young babies similar to adults do show musical sensitivity to musical scales and temporal regularity. um, of course, by 2 month old, babies do respond to consonant versus dissonant. By 6 to 9 month old, they are able to appreciate the isochronous temporal pulse, like the one that I showed earlier, the first example. Uh, and by 3 year old, they're able to appreciate happy in music. And by the time they are about 10 to 11 year old, they're quite well equipped, just like adults, to appreciate several features of music and features of rhythm, and appreciate the emotional and other intricate perception of music and rhythm perception. Um, I thought I'll take you through how tempo plays an important role in emotion perception, which key point that I mentioned earlier on. And just before I dwell into that, let me quickly take you through. It's almost like a bird's eye view, not even like going in depth, just to make you appreciate that the work we did included samples from Indian classical music, specifically Hindustani classical music. There are two traditions, and in both these traditions, the melodic aspect of it is based on what we know as ragas, or permutation combination of musical notes. And each of these ragas are assigned to certain rasas, the emotion or the emotional experiences. A given raga can evoke more than one emotion. All that I will not go lot detail into it, but to the point that to explain what exactly we did in our study. And when we talk about Indian classical music and raga elaboration, you would have seen that in a kacheri or a concert, an artist would present a raga for about half an hour or 40 minutes. And what the artist does actually is to take you through different phases of, exploring or creating this raga, and creating new features of this raga, and perhaps that's artistic component of it. But interestingly, the artist would also kind of vary inherently certain features of the music itself. In traditional forms of Hindustani classical music, an artist would present the raga without any rhythm aspect to it, although there is an unmeasured pulse that goes on. We call that as an alap phase. In instrumental presentation of the raga, this phase is followed by what we know as Jorjala, where pulsation comes in. I'm going to play example of that to kind of explain this perhaps with more clarity. But then comes in the third phase of raga elaboration, the Gat or the Vilambit, the slow presentation of a given raga with a set composition. Then followed by Dhrit, where the tempo increases. Now, as I mentioned earlier on, we know theoretically and we know otherwise that tempo, varying tempo, can actually vary the emotional experiences. Now, when we talk about Indian classical system, when you talk about this raga elaboration, there is actually a variation that's happening inherently of all these features, starting from slow to increased tempo, along with the melodic changes that happen. But an artist will be held within the framework of the grammar of a given raga. So I'll present an example of the alap phase of the same raga and the Jorjala before I actually explain what our findings were. Okay. Here, the sorry. So here in the presentation, the pulse is so apart that it would be very difficult for a normal person to actually, have a feeling that there is a pulse or a beat in this presentation. We cannot call that there is no time aspect at all to it, no rhythm aspect at all, but it is not coming within the framework of normal perception of a given beat. It's too far apart for us to psychologically at the cognitive level to experience a sense of beat. Whereas when it comes to Jorjala, the artist would present with certain pulsation. There may not be an external percussion instrument or meter or external beat that I mentioned, but there is definite pulse that one can experience. So this was just some small example of Alap in the same raga and the Jorjala in the same raga. In what we did in our experiment was to see if people who are not trained in music, formally trained in music, did they see any difference in in experiencing the emotion. We took set of ragas. This was just one of the example taken. We took about 10 different ragas based on the traditional Indian music theory. And what we found was 5 to 6 year old children, when we presented these musical excerpts, they did not really worry much, or their emotional rating did not change with the change in tempo. Whereas a 10 to year old children, they were able to mention or say that the rating of the arousability or increased intensity of the emotion experience changed with this change in tempo or the pulsation. What about adults? What we found was that with the Alap and the Jorjala, with a set of ragas, about 10 ragas from the Hindustani classical tradition, as I mentioned, what we observed was the difference between 2 or 3 ragas during their Alap phases was far wide compared to within, between the raga was far smaller compared to within the raga. Now, what does that mean? That change in tempo actually changes in the intensity of the emotion experienced or the arousability of the emotion experience. So this actually is a challenge when scientists have to carry out research in the field of music and cognition using Indian classical music tradition. Perhaps it would be very challenging to say, use this raga and then examine the raga as such, because you'll also have to be careful which raga elaboration that you're talking about, and what rasa that you're talking about. Here, what we found was that negatively valenced ragas, that which kind of evoke sadness or melancholy or longingness, when it increased in tempo, actually brought out emotions such as anger, fear, rather than happy and joy. That changes with tempo in the positively valenced. So there is this inherent interrelationship between the melody and the tempo, change in tempo. So to summarize in this particular study that we did with children and then later with adults, that Indian performers definitely have the possibility to strongly wear the expressivity associated with specific raga and by their performances, but within the constraint of the raga. But the tempo also plays a very, very crucial role in determining the valence and the arousability of the raga. Now, let me take you to the last bit of my talk, looking at music, rhythm, the brain, and what is the understanding in the clinical application and translational research. There's a lot of work happening. Time would not permit me to go through several of these studies, but I'll just give a bird's eye view into the clinical application of music and rhythm in this especially starting with Parkinson's disease, because Parkinson's disease is one of the most common and the largest, second largest neurodegenerative condition. And as we all know, Parkinson's disease affects motor functions, mainly slowness of movement, bradykinesia, as we know, muscular rigidity. There is resting tremor, and there is also postural imbalance. In addition, what we know in the recent time is that not just the motor functions, the non-motor functions also play a very important role in this clinical condition. Now, the area of the brain that's implicated is basal ganglia. Let me remind you again that the very same area, the basal ganglia, the putamen, and the motor pathway is implicated in rhythm perception and beat perception. So non-motor functions include cognitive deficits, sleep disturbances, depression, and several other clinical symptoms that play an important role in determining the overall quality of life in this clinic degenerative condition. So basically, it's a degenerative condition. Nevertheless, a lot of research is going on, like in Alzheimer's and other degenerative conditions, to find out if there could be intervention programs that can have prophylaxis effect, if not complete cure. To begin with, in our lab, what we examined was that on one hand, Parkinson's disease have impairment in basal ganglia, and mainly the putamen, the substantia nigra, and the whole motor pathway. On the other hand, there are a lot of research that has shown that the very same population benefit from rhythmic auditory cueing. That's one of the widely used technique where rhythm cueing is provided to individuals to help them with their gait and cadence. So you give it's all based on the principle of this rhythmic entrainment, an external cue engaging the internal motor cueing that happens, and this in turn facilitates movement planning and thereby benefiting their walking and gait. So what we looked at was not just motor functions. What about the non-motor functions? So we set out to do a study to examine how different features of rhythm, what I mentioned earlier on, beat, meter, pulsation or beat within a musical context, how do our patients with Parkinson's perform? Is it that one feature do they have a problem with in perception, but do they have problem in all aspects of rhythm features? So what we did was to give them multiple rhythmic tasks like rhythm contour for them to we made them respond saying that whether these two given examples of rhythmic contour were same or different. Metrical example like 2 beat versus 3 beat, or metronome coming in a musical context, asking them to say if certain metronome placed on a given musical context, was it on beat or off beat. I'll just give you one example of each. So this was an example of rhythmic contour. So our patients had to say whether the rhythmic contour is same or different. So in this example, both these audio sample that came had same rhythmic contour. There's an example where that was not the case. Okay. Although the notes used in this melodic line was the same, but the rhythmic contour differed. This is an example of meter, which we asked them to say whether it was a 2-beat meter or a 3-beat meter. So basically, you'll have to count if it was 2-beat in that melodic line or 3-beat. So there is an upbeat followed by 2 low beat, making it as 1 2 3 1 2 3 1 2 3. And Here is an example of a metronome sound placed over a melodic line but coming offbeat. So patients had to tell us whether it was the same or different, whether the tempo was on beat or off beat. Is this not giving me? 1 second. Let me play this example. So basically, in this example, the beat is much faster than actual beat. So patients and matched healthy control in this study, who are matched on age, education, and gender, had to tell us whether this particular metronome that was placed on the melodic line was same or different. In fact, these are all part of standardized tests that are used in rhythm perception by neuropsychologists. So what we found was that patients with Parkinson's perform poorly on all these different features of rhythm perception. But this was not just our interest in the study. What we were also interested was to look at if it kind of predicted the non musical domain of cognitive functions. What we found was their performance on these rhythm perception tasks correlated significantly in the domains of attention, working memory, in the non-musical domain. And not just that, these performances also predicted their performance in the non-musical domain of functioning, non-rhythmic domain of cognitive functioning. So focused attention and verbal working memory predicted their performance on rhythm tests. And beat discrimination, beat perception in this musical context, and discrimination of rhythmic contour predicted their performance on these neurocognitive functions. So, which is actually taking us to the next level of saying that not just that music is ubiquitous, music is biologically based, it definitely has shared neural basis with other cognitive processes like language, motor function, and non-musical domain of cognitive functions. What we know today is that music and rhythm perception engages a whole lot of cognitive functions, and music in neuroscience is considered as a food because you are able to understand the functioning of the human brain through this phenomena that is music and rhythm, and it is considered as one of the higher cognitive functions. And by engaging several of these cognitive functions, music and musicians are considered as a role model to understand this phenomenon of neural plasticity. I understand that in previous talks of this Brain Awareness Week, many speakers have touched upon this concept of neural plasticity. What basically it means that the brain has an inherent ability to adapt to the environment and engage these functions or changed environment and bring about structural and functional changes. This happens naturally, developmentally. Neural plasticity does occurs, but more so neural plasticity is the key or the crux when we are talking about this translation that happens in our understanding of basic science to developing intervention program in clinical condition. When there is an injury to the brain, can we help this injured brain or affected brain adapt through other functions that are still intact and be able to help the individual get back to near normal functioning, if not normal functioning? So Raymond A. Kahal actually mentioned about musicians and the importance of studying musicians, such as pianists, in basically understanding neural plasticity. Of course, there was, as I mentioned, music cognition had a long history, but in the last 2-3 decades, it has kind of expanded so much that thanks to technology like imaging studies, EEG studies, MEG, SPECT, and PET studies, which have helped us understand and study not just the clinical population but also the other spectrum of group, the highly trained musicians, to understand this concept of neural plasticity. So neural plasticity for a person like me or neuropsychologists, is the crux as the rationale for cognitive remediation to improve cognitive functions, which often gets affected in several clinical conditions, across clinical condition, and play a very important role in helping functional recovery and improve overall quality of life of a given individual. So, as I said, neural plasticity underlies normal development and maturation, but it also occurs when there is specific inputs given to the brain following an injury or following a clinical condition. So, for example, in cases of Parkinson's, schizophrenia, you name it, epilepsy, depression, now cognitive remediation, focusing on improving cognition is considered to be an important part of treatment regime. The whole challenge, of course, is to see if any intervention has not just the near transfer of the task given. In this case, if it is music and rhythm based intervention, but also far transfer. Can it have impact on other non musical domains of cognitive functioning? So the example that I gave of our work of Parkinson's and looking at its close interrelationship between cognitive function and rhythm perception is one such thing, where we are actually saying that improving music perception or doing tasks that are based on music and rhythm perception can have impact on the non-musical domain of functioning. There are several studies done in the recent times in children to improve language perception in children and adults who have had language disability, with training of rhythm perception, rhythm-based activities to improve phonological processing and language processing. So currently in the field of music intervention, the neuroscience-based model is known as the neurologic music therapy. It has mainly three main components, which focuses on sensory motor functioning, speech and language functioning, and cognitive functioning. There are several techniques in each of these. A person has to be trained in this as a clinician, as well as in the form of neurologic music therapy to administer it. I'm going to take you through it quickly to make you appreciate how crucial rhythm perception and rhythm component is important when we are talking about the intervention module. When it comes to sensory motor functioning, like as I mentioned, the rhythmic auditory stimulation, the whole science behind it is how rhythm actually engages this auditory motor pathway, the reticospinal connections, and thereby entraining this motor functioning as well as through the external cueing. So rhythm entrainment, priming of this auditory motor pathway, and cueing of movement period. That means from beat 1 to beat 2, we anticipate the beat 2 coming. By entraining this in our motor functioning, we're actually helping the person to plan their motor functioning, like next step, when do I have to play, how much should my cadence be, how am I going to plan my movement. I'm going to show you a small video of a case that we had seen in our clinic, and this is a case of head injury, not Parkinson's, where we used singing and especially highlighting the rhythm component of it in her gait training. And in fact, her physiotherapist had said she had absolutely good muscle strength to walk, but she had other psychological and neurocognitive deficits. And we also used RAS in improving her gait. So I'm just quickly going to show you this. She's singing along. She's also trained. She was trained in music. She was a choir singer. Unfortunately, met with a road traffic accident and had difficulty in planning her gait. So the clinician actually gives sound either through a recorded music or sings, but mainly highlights the rhythm aspect while doing this therapy. So the whole science behind this is this auditory motor action coupling schema, wherein your external cueing, auditory pathway, there are different areas of the brain that are implicated, and there is an inherent motor pathway within which both gets coupled and enables this motor entrainment to happen to the external rhythmic cueing. The next domain is speech and language functioning. As I mentioned, there's a lot of research happening now. Even one-time rhythmic cueing and rhythm-based exercises benefiting in speech and language processing. And in speech and language domain, there is one technique called the melodic intonation therapy, where the melodic intonation is highlighted when individual is given training to improve their aphasia, like Broca's aphasia. The crux there is highlighting this melodic intonation, of course, but inherently the crucial component there is the beat or the rhythm aspect to it. In certain clinicians use tapping as well, and some do not. But tapping is also known to have additional benefits when this treatment program is helped with. The other is, of course, cognitive functioning. Now, this is, of course, the recent frontiers in the field of NMT and lot more. This wide gap, of course, from the neuroscience research versus the application research. There's a lot more research that needs to be done to see how music and rhythm based exercises actually benefit in cognitive function. What we know is it engages the prefrontal functions, the higher cognitive functions, the entire prefrontal pathway that facilitates cognitive functions such as attention, working memory, and other planning and other executive functions. So let me conclude here saying that music and rhythm is a biological phenomenon. It's not just a mere socio-cultural phenomena. And rhythm and music are, like as I said, the two sides of a coin. And entrainment to this rhythm seems ubiquitous in human cultures, across cultures. Um, the ability to perceive, produce, and enjoy music is typical human trait. And rhythm is intricately, very closely connected with motor functions, cognitive functions, as well as emotion functions. I have given example for each of these, although I've not gone in depth. I've tried to give you an idea of how rhythm perception is extremely crucial. And what we know is that it has in the brain, there are dedicated areas of the brain that are specifically for music and rhythm, but it also overlaps with other functions like language and motor functions. And therefore, this translation is something that is viable, that is explored, and that evidences are coming through to say how music and rhythm based intervention can have benefits in these various domains of our functioning, and not just in the domain of music. So the whole goal of music-based intervention, neuroscience-based intervention, is not to make our patients musicians, but to tap this inherent trait that all humans carry for music and rhythm, and enhance it to help them gain or recover from various clinical conditions. So, power of music and rhythmic activities has been recognized. It's certainly exploited for neuro rehabilitation and neurological conditions. There is, of course, a lot, need to do systematic research. In, of course, a lot of work that has been done in the Western scenario, but a lot more that can be done in our country using, culturally more closer traditions of music in our country. So they say every disease is a musical problem, and every cure is a musical solution. Of course, this was by a poet, and I'm sure very soon that would be true. That, for example, in Parkinson's disease, we know there is an inherent rhythm deficit and motor deficit, but the cure could also be through music. That is music-based intervention. So I thank all my lab mates, my colleagues, my students, who are all integral part of this laboratory at NIMHANS. And ours is a young lab. We have started working both from looking at music and cognition, but also simultaneously developing modules for intervention program. Hopefully in the years to come, we would have a lot more data to share, scientific data to share. And I thank my collaborators, which we have funding for from the Wellcome Trust India Alliance. And thank you all. So I'm open for any questions or.
Thank you so much, ma'am. It was so thought-provoking. I'm sure a lot of people have got insight about how music is so much beneficial for the brain. Uh, so, ma'am, we'll move on to few questions. Are you able to hear me, ma'am?
Yeah, yeah, I am.
So I'll pose some questions. People who are tone deaf or can't predict the next beat aren't neurologically intact. So is this reversible over prolonged exposure to music? I'll repeat. So people who are tone deaf or can't predict the next beat,
Hmm, hmm.
uh, they aren't actually neurologically. There are no issues with them, but then so is this reversible over prolonged exposure to music? That's what the doubt is.
Okay, so as I mentioned, um, like most of us, 90%, 96% of the population are musically talented. May not be, I'm not saying that everybody will become musicians or musically proficient, but all of us inherently have this basic uh, ability to perceive and engage with music, and only a handful of them are tone deaf, and these are congenital conditions. So it's just like saying, people with specific learning disability, they may have certain deficits in language processing. It's a neurological condition, so we can't say that they don't have any problem, but their overall ability to adapt to the environment, their IQ is fine. So it is not that children or adults who have specific learning disability have other neurological issues. Inherently, they have this deficit. That's what I'm trying to say.
The next question. Could you mention the tools used for studying neuromusicology and what are the limitations of experimental techniques pertaining to music as a stimulus? So, certain tools that are used for musicology, can you mention few of them?
So, as I presented a few examples, they are from standardized tests. There are batteries of amusia. There are stimulus that are developed was for specific experiments. The one I presented on musical context and the metronome on it was from Patel and Iverson, who have developed this tool to study beat perception in musical context. So there are several such tests that are developed and standardized. But depending on, just like in the field of cognitive neuroscience, depending on your research question, you may develop certain musical stimuli or pitch or rhythm based stimuli for answering your research question. Now, just to share what I experienced initially to begin with was that if you, as I said, you can't just take a raga and then say I'm going to do experiment on raga. If I take given raga A, what about B, C, D? There are hundreds of ragas, as we know, in the Indian tradition of music. Now, if you go by the cognitive neuroscience school of thought, then you're actually looking at features of music. So you should pay attention to what is the tonic note, what timbre you're using, how are you controlling for tempo, how are you controlling for various other features. So your stimuli would depend on your research question, on the school of thought and the approach, as I said. So all this can be a bit challenging yet exciting.
The next question is, do different rhythms and pitch have effect on the brain rhythms? And could you discuss some studies for the same? So, and another question by the same person is that is there any concentration music that could help us align our brain activity?
So I did not present that study. One of my student actually looked at one-time music listening, which had a particular tempo in it, on in patients with schizophrenia and its impact on attention allocation. So we did a P300 study, ERP study, EEG ERP study. So the challenge in the field of neuromusicology and music cognition is that this terms like beat, tempo, rhythm are sometimes not clearly used. So each one has their own explanation to say, okay, pulse versus beat versus thing. But if the question, if I've understood correctly, two different types of rhythm on the cognitive function, that is something I don't think has been studied so far. Two types of beat in, you may actually look at meter perception. There's different types of meter have different types of uh, effect on other cognitive function. What we know so far is that anticipation, it could be any such beat, upbeat or a low beat, the stressed versus less stressed beat, can help in this attention allocation. I hope I've answered it. I think I've understood the lesson correctly.
The next question is by Vani. Is auditory imagery also observed in synesthesia, and can this auditory imagery take place in people without synesthesia as well?
Can you
That is,
repeat the
yeah.
question? I couldn't
Is,
hear it.
is auditory imagery also observed in synesthesia,
Mhm.
and can this auditory imagery take place in people without synesthesia as well?
Yeah, synesthesia is a phenomena where one sensory modality can activate another sensory modality. And the most important aspect of music perception is visual imagery. There's a strong evocation of emotion and visual imagery. Even in our studies, we have actually taken subjective experiences, subjective report of subjects, what they actually felt, what they actually saw, or what came through their mind. Can music perception happen without visual imagery? Perhaps. I'm not aware of studies where this has been specifically looked into. But I suppose there are differences between musicians and non-musicians. So if you're asking about musicians and performance and their way of perceiving or understanding music, then the whole process would be quite different than those who have not been trained. They would be more focusing on the feature of the music. Even in one of our fMRI studies, we have seen that musicians process it quite differently than non-musicians.
Okay, so the next question is: does brain activity differ while performing practiced song versus during a novel composition or while impromptu improvisation? That is, how is the brain activity different in a practiced song and a novel composition?
Yeah. In practice song, of course, after a point, it's again from an evolutionary point of view, brain would not want to expend unnecessary energy. So the moment it becomes a practice, anything, it need not be just music, it takes into the subcortical area. Anything novel would actively engage the prefrontal areas. So you have to keep yourself updated in terms of time, because music unfolds over time. If you're learning a new music with rhythm, you need to keep yourself alert. So your working memory, your attention, your information processing has to be at its peak. Now, the moment you have already learned, the activation is through your long-term memory. I recollect a song, I recollect a lyric, and I'm kind of comfortable with the rhythm. I know when the meter is coming, or when the first beat is coming, or the end beat is coming. Coming to the third point of creativity, that is spontaneous, spontaneous. What was the term that was used? I'm sorry. Creating a new tone or new melody. What it is known as in jazz musicians, there have been studies where the prefrontal activity kind of gets subdued, and it's more of the parietal area. So more visual imagery, which means that, of course, if you are creating music, you're already kind of proficient with the basic aspect of the composition, and then you create on top of it. But
That's
even
really
there, you need to keep you have to keep yourself updated with the external rhythm and the external cue that happens. That's part of any creative process.
I think we'll go for the last question now. So, because of brain plasticity in musicians, will music therapy affect musicians and non musicians differently? This was answered before. So, especially in sensory motor functioning, as you explained with the example of the classical singer who is being treated for gait with rhythmic music. So, brain plasticity in musicians. So, the question is, will music therapy affect musicians and non-musicians differently?
Okay. This question is very very important in the sense, first point, musicians are not kind of immune to any clinical condition. That's one message that I would like to say. It's not that music is be all end all, and just because I said it activates all the entire brain region, and it is the one of the best tool for cognitive gym or cognitive keeping your cognition kind of alert. But yes, music does improve your cognitive reserve. So musicians, we expect them to have good cognitive reserve because of this intense training that they go through. Thirdly, do they benefit from music based intervention differently than non musicians? We don't have so many studies, first of all, to see the difference between musicians and non musicians. But yes, in conditions like Parkinson's disease, the recent research question has been those who have good rhythmic sense pre-morbidly, are these patients respond to treatment differently or better than those perhaps who do not have an inherent liking or a sway for rhythm. But musicians, when you're using music clinically, we have other challenges to face. So yeah.
Okay, ma'am. So I think we'll come to an end of it. I'm sure the session was fascinating and people mostly go into the emotions and get swayed away with the music. So now we have a neurological or scientific view of it. Thank you so much, ma'am, for this wonderful lecture that you have given. And I thank all the viewers who have been part of this. And you can check on the website for other competitions of brain trivia and case studies. The next session will be at 9 o'clock. So hope to see you all there. Thank you so much, ma'am. Thank you,
Thank you.
everyone.
Thank you. Bye.